Hey boys and girls, it's day 10 for our math review, and today we're going to be covering fractions. So our first fraction activity we're focusing on, or lesson that we're focusing on, is fractions on a number line that are greater than 1. And then we're going to focus on just equivalent fractions. And lastly, we'll focus on equivalent fractions on a number line. But before we get started with that, let's go ahead and take a look at our problem of the day. All right, here we go. And it reads, Harold had a collection of 92 baseball cards. He got 53 new baseball cards for his birthday. How many baseball cards does Harold have now? Show or explain how you know. So, what are the numbers that we have? We know we have 92. We also know we have 53. So what is important about this information? These are the numbers that we have. Now we need to know what we need to do with these numbers. So Harold had a collection of 92 baseball cards. So we know 92 is important. He got 53 new baseball cards for his birthday. How many baseball cards does Harold have now? So just think about this. He had 92. Then he got 53 new cards. So which operation am I going to use? Am I going to use addition, subtraction, multiplication, or division? That's right. We're going to add. So we're going to do 92 plus 53. And the great thing about this, we don't have to do any regrouping. We don't have to take it to the neighbor. So what is 2 plus 3? It's 5. That's correct. What is 9 plus 5? 14. So what is our answer? 145. So how many baseball cards does Harold have now? Yes, 145 cards. Remember, do we say and when we read a number? No. And we only say and when we have a fraction or a decimal. Let's go ahead and move on. Fractions on a number line greater than 1. So we're going to take a look at this Explore and Grow. It says divide each circle into halves. Shade 3 halves, write the fraction. That sounds simple enough, doesn't it? So I'm going to go ahead and divide these two circles in half. Simple enough. Now it's telling me to shade in how many parts? 3 parts. So you know how I do. I don't shade the whole thing in. 1. Man, I am just all out of the circle today. All right. So I've shaded in 3 parts, just like it asked me. So let me ask you this, because we've gone over this. We've done this before with mixed numbers. So how many halves do I see in one circle? 2 halves, okay? So that's the one fraction that I'm focusing on. I know that I see 2 halves, so my denominator is going to be 2. Now, what I'm going to do is I'm going to count all of these parts right here. So how many parts are shaded in all? I see 1, 2, 3. So this will read 3 halves. Do you see that? Good. Now, complete the fractions on the number line. Plot 3 halves on the number line. What do you notice? Well, I know that this would be 0 halves, 0, 2. And I know the next one would be 1 half, because it's split into 2 parts. And then I see the 1, so what is the 1 going to represent? 2 halves, 2 over 2. All right, so we have 0, 1, 2. So what do you think is going to go right there? 3 halves. Good. And then if we want to take it up a notch and keep going, this will be 4 halves. So if you were trying to figure out 4 divided by 2, that equals 2. Just like 2 divided by 2 equals 1. So 4 divided by 2 gives us 2 whole, while 2 divided by 2 gives us 1 whole. So let's get further into our lesson, get a deeper understanding. Think and grow. Fractions on a number line greater than 1. When the numerator is greater than the denominator, the fraction is greater than 1 whole. You can show fractions greater than 1 whole on a number line. So let's take a look. If we see this right here, this is showing us 1, 2, 3, 4 parts, okay? And this is showing us 1, 2, 3, 4 parts as well. But how many parts are actually shaded in? So if I take a closer look, I see 1, 2, 3, 4, 5, 6 parts are shaded in like all together. But then remember, just one of those has 4 parts only. So that means it's going to be 6/4. And for my friends who want to extend it with the, to extend their thinking, it'd be 1 2/4. Remember when we did our mixed numbers? So 1 2/4. So 6/4 is equal to 1 2/4 because we had 1 whole, and then the second fraction just had 2 parts shaded in. So now you would like us to plot this on a number line. So plot 6/4 on the number line. Divide each whole into blank equal parts. So how many equal parts will take up 1 whole? So we just take a look at this example right here. And if we look carefully, I see 1, 2, 3, 4 parts. So 1 whole is equal to 4 equal parts. So label each tick mark on the number line. Think 1 is 1/4. 1 1/4 is 1/4. 2 1/4 are 2/4. So plot 6/4. So let's count. So we got 1, 2, 3, 4 1/4. But I want to get to 6/4. So how many more do you think I should add? 2 more. So 5, 6 2/4 right here. So that's where my 6/4 would be located, right there, because I counted 6/4. And then I would go to the one that's at the end. If we take a look right here, we can label this easily. So that's 0/4, 1/4, 2/4, 3/4. What's going to go right here? 4/4. Good. And then we've got 5/4, 6/4, and 7/4. So what do you think is going to go right here? 8/4. All right. So how many fourths did it take us to get to 6/4? And we just take a look at this again. 1, 2, 3, 4, 5, 6. So we would literally write 6 1/4 are 6/4. So show and grow, show me what you know. Plot 15/8 on the number line. 15/8 on the number line. So if we take a look, I see a lot of 8s on here, don't you? So we need to draw our lines to line up with this. So I'm drawing my lines just like you should be. Because it makes it easier to see it that way. All right, so this would be 1/8, 2/8, 3/8. This is going to get a little more challenging the closer I get. 4/8. 5/8. That's a 5, just in case you were wondering. 6/8. 7/8. And then of course, when we get to 1 whole, that is 8/8. Now, you're gonna have an easier chance of writing on here than I am. So I want you to keep going. So this line right here obviously will be 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, and then we've got 15/8 right here. And I'm gonna go ahead and plot that on this number line, 15/8. And of course, 2 would be 16/8. So like I said, when you do that math in your head, 16 divided by 8 equals 2. So that's how it is 16/8. So now we're going to apply and grow. Plot the fraction on the number line, 7/4. So they made it very easy for us today because what they've done is they have taken these fraction strips and just place them across the line. So all we have to do, like we did before, draw our lines to represent where they're located on the line. We see 0 right here and 2 right there. So that means it has to be in between 0 and 2. But when we really think about it, are we going to get that far? So there's my 1/4. 2/4, 3/4. That's a 3. Sorry, guys. 4/4. 5/4. Six fourths. And then look at that, 7/4. Oh, that's awesome. So 7/4 is located right there. And if we get to the end of this strip, that would make it 8/4. And when we think about it, division-wise, 8 divided by 4 equals 2. So we have plotted 7/4 right there. So once again, this is asking us to split it up into 6 and into thirds. I'm going to go ahead and do the 6 with you, the 9/6 with you, and you will do the 5/3 on your own. So I've told you before, when it comes to 6, we split in half, and then I add 2 lines on this side and 2 lines on that side. Once again, split it in half, 2 lines over here, and 2 lines over here. And that gives us perfect equal parts in between 0 and 1, and then once again between 1 and 2. So 9/6, I know that would be 1/4, 2/4, 6, I'm sorry. So let's try again, 0/6, 1/6, 2/6, 3/6, 4/6, 5/6. Obviously 1 whole is going to be 6/6. Then we have 7/6, 8/6, 9/6 right here. So 9/6 is directly in between the 1 and the 2. So there we have plotted 9/6. So now what I will do for you on this side, I will assist you with creating your thirds. As you see right here. And at this time, I want you to go ahead and go across and label all your thirds. So that's 1/3, 2/3, 3/3. and go from right there. All right. So your answer for number 4 should have been right here. You should have been able to plot 5/3 right there. Awesome. Let's take a look at question number 5. Complete the number line. So this is simple because what we're going to do is we're going to count the parts first in between 0 and 1, and that's going to help us figure out how many equal parts there are. So I see 1, 2, 3, 4 equal parts. So that means my denominator should be what? 4 all the way across. So I want you to go ahead and label 4s all the way across like so. And you know me, I have to put something right here, even though it's not showing it, because that helps me to determine what should go right there. So if we have 4 fourths right here, then that should be, then we're going to end with 8 fourths right here. So you, at this time, go ahead, pause the video, complete the rest of this page to get your answers out the way. I'll be here when you get back. All right, now let's take a look at this. Think and Grow, modeling real life. So I like this modeling real life because now you're thinking, what are we doing, a map? Well, not really. We're still doing a number line, but if we take a closer look, you see that this map has been divided into what? And I made a boo-boo right there, but that's okay. It's been divided into halves, okay? Because if you take a look, there's 1, 2 parts. So my denominator should be 2. Now, the question is asking, how far is the aquarium from the bank? So I see the bank is right here, and I see the aquarium is right here. So if I see the bank right there and aquarium right there, that means I have to locate where this aquarium is on the number line. So I have 0 halves, 1 half, 2 halves. So what does that mean this is? 3 halves. Good. And then of course this would be 4 halves. So the aquarium is blank miles from the bank. 3 half. And for my friends who want to take it up a notch, 3 halves or 1 1/2 miles. Now you're going, how'd you get 1 1/2? Because I know that this right here is located midway between 1 and 2. So it only makes sense for it to be 1 1/2. All right. Now I'm going to help you think a little deeper what you're showing Grow. Use the number line to answer the questions. So I'm not going to help you with all of them, but I do want to help you with a couple just so you can kind of see it and see how it works. I'm going to move this over here just a little bit so we can see everything. So if we take a close look, it says use the number line to answer the questions. So I see school right here, library, gas station, amusement park, restaurant, and hospital. How far is the gas station from the school? So here's the school, and here's the gas station. Now, if I look closely, I see there are some fractions already located on this number line, and they have a denominator of 4, which means that this has been split into 4 equal parts between each whole number. So between 0 to 1, then 1 to 2, then 2 to 3. So if this is the gas station and I know that the library is at 3/4, then I know 1 is at 4/4, which means the gas station is going to be at 5/4. Very good. So how far is the gas station from the school? 5/4 mile, which is also equal, who can tell me, what whole number did we just go past? 1, and then what's the first tick mark? 1 1/4 miles. So I'm just going to put it MI, because that represents miles. All right. So I want you to take a look right here. A post office is the same distance from the restaurant, there's a restaurant, as it is from the hospital. There's a hospital. So how far is the post office from the school? So they're saying that the post office is the same distance that you would take from the restaurant to the hospital. So that also means how far is the post office from the school? So we have to take a look. The restaurant to the hospital. So I'm going to count how many fourths these are separated by. So I know that the restaurant is located at 10/4. And I know that this hospital is at 12/4. So how many fourths does it take for me to get from the restaurant to the hospital? 2/4. Very good. So your answer, literally, 2/4 mile. Because remember, I told you, they're saying that the post office is the same distance from the restaurant to the hospital. So that means the post office is going to be the same distance to the school. That's 2/4 miles. All right, so now what I want you to do is I want you to try to do the same thing with the gas station. How far is the gas station from the hospital? So here's the gas station, and there's the hospital. And I want you to count the fourths and tell me how many fourths it is away. So 1, 2, 3, 4, 5, 6, 7 fourths. And for those friends who don't know what 7/4 looks like, 7/4 is equal to 1 whole and 3/4 mile. All right. So at this time, I want you to go ahead, dig a little deeper, and answer number 12 and the rest of this page on your own. All right, welcome back. Now we get to move on to equivalent fractions. So right here in our Explore and Grow, it shows us a diagram. We've seen something like this in our math books before, right? So use the model to write fractions that are the same size as 1/2. So here is 1/2. I just divided it all the way down. That's representative to 1/2. So, and there's 1/2. So which pieces would equal 1/2? Can I say it's 1/3? No, I cannot. 1/3 is not equal to 1/2. Now, 1/4, if I put these 2/4 together, guess what they do? 2/4 is equal to 1/2. All right, what about 1/6? How many 1/6 do I see? 1, 2, 3. So I have 3 1/6, and those actually equal 1/2. And then if I take a closer look at these eighths. How many eighths does it take to equal 1/2? That's right, 1, 2, 3, 4 eighths. Now, if we take a closer look, it says, can you write a fraction with a denominator of 8 that is the same size as 3/4? So 3/4 would end right here. So I have 1/4, 2/4, 3/4. So I would need to count all the way to right there to see how many pieces that is. Can you tell me how many pieces you see that get me all the way to 3/4? Go ahead, you can whisper, you can whisper. Yes. 6/8. So that means 6/8 is equal to 3/4. So we just did our explanation right there. We counted literally the same amount of space from 3/4 right here at the top, and then the 6/8 takes up the same amount of space. So Think and Grow model equivalent fractions. So 2 or more numbers that have the same value are equivalent. 2 or more fractions that name the same part of a whole are equivalent fractions. Example, use the models to find an equivalent fraction for 2/3. Both models show the same whole. Both models are taking up the same amount of space, if you notice. But if you look very carefully, the lines go like this on this one, while the lines go down and across like this on this fraction piece. They still take up the same amount of space. The only difference is there are more parts in this one. So if we take a closer look, it says 2/3. And then how many shaded parts do we have right here? 4. So 2/3 is equal or equivalent to 4/6. Now that word equivalent, what does equivalent mean? Equivalent means equal. Good job. So 2/3 and 4/6 are equivalent fractions. So 2/3 equals 4/6. Awesome. Use the models to find an equivalent fraction. Both models show the same whole. So what we have to do now is we have to shade in these parts that they're asking for in order to be able to answer the question. So Show and Grow, show me what you know. Look at question number 1. I see one whole. Give me a moment, boys and girls.
Mommy, your TV's not coming on.